inaugural session here for the Borum Reply Databricks user group. So I'm pretty excited to get this kicked off. Really, the premise is just to try and have a community around Databricks and some of the related technologies. But ultimately, we're going to be looking, for guidance from everyone who's participating on what you want to get out of this too. So to kick things off, let's go ahead and just go around the room real quick and do some introductions. I'm interested to hear about what work you're doing, where you work, and what level of data experience or Databricks experience you already have. So let's go sort of in alphabetical order here from the attendees list. So go ahead and unmute yourself, and then you can just introduce yourself. So Akil, let's start with you.
Hi, my name is Akhil Mahajan. I'm a senior data architect with Hitachi Solutions. Been working with Databricks about a year now. Getting into more about machine learning and data engineering side. So trying to learn more about Apache, more about performance. So that's what my goal is.
Great. Okay. Yeah. Thank you. And by the way, feel free to include any topics you're interested in learning about too. I'm always eager to hear about that. Okay, Amy.
Hi, I'm Amy, and I'm working for IPFS, and I'm a machine learning engineer. And my company is trying to move away from Tableau to all the Microsoft softwares. So this will be my first session of learning about Databricks.
Cool. Okay, Christian.
Yeah, hi. I'm Christian. I'm from Germany, working for Cluster Reply, and I'm a data engineer. I'm working with Databricks since 6 months roundabout.
Okay, awesome. David.
David Taylor with FedEx Express. I'm a data scientist. We're using Databricks to predict when parts on our aircraft will fail before they fail, so we can plan and schedule for maintenance before failures occur and delays occur.
Cool. Okay, John. I see you unmuted, John, but we can't hear you. I can come back around if I need to. There we go.
All right, great. Yeah, so John Gabriel here with United Lex. Pretty new to Databricks. Went through a session with Spencer probably a month and a half, 2 months ago now.
Yeah, time flies.
Yeah, it does. And so, yeah, I lead a data insights and integration team at United Lex, and just looking to learn more.
Okay, great. Lindsay, I'm going to skip you. And I apologize if I butcher anyone's name, but Kartik. See you unmuted too, but I'm not getting audio yet. We'll come back around. Randy?
Yeah, like David, I'm also with FedEx Express. I'm a data engineer. Been using Databricks a couple of years now, so looking forward to it.
Okay, awesome. And then Sean?
Hi guys, I'm Sean Esser. I'm a data-focused cloud solution architect with Microsoft. I work in the federal, specifically the national security space, and use Databricks every day. Just very interested in hearing, interesting use cases. Just trying to expand my knowledge of it. Thanks.
Cool. Okay, and Shreyansh?
Hey all, so I'm Shreyansh, working as a data engineer. So I've been using Databricks since 7 months now.
Okay, cool. Well, okay, and Kartik, did you ever get your microphone going? We can try that again. No dice. No worries. You can just respond in chat. So I was teasing Lindsay about skipping her. I want to think we've got Lindsay Rain, Naresh Koka, and Rachel Arnold are in here as moderators from Valorum Reply. They're part of our marketing team and helped me set all of this up. So thanks to them for getting it started. Just to introduce myself a little bit more broadly. So like I said, I'm Spencer Cook. I'm a data scientist at Valorum Reply. I'm on our data-driven enterprise team, specifically on the data science and AI team within that. I'm a Apache Spark certified engineer and a Databricks champion. So hopefully I can at least get some portions of this right. But you're always welcome to reach out to me outside of these sessions too if you have any questions about certification or best practices, that type of stuff. But really, again, the goal of this is to just try and get some community engagement started around this, and help each other understand how best to use this Databricks platform to achieve business goals. So to kick things off, it sounds like everyone has a pretty good level of experience with Databricks, but I want to go ahead and go through some introductory slides just about how Valorum has sort of philosophically approached Databricks so far and what we see as some of the intriguing aspects of it. And then after that, we're going to move over to the actual topic of the session, which is structured streaming. So we'll have a PowerPoint deck for that and also a demo. So really the goal for Databricks is to try and accelerate insights for businesses and thereby improve their performance, right? And Databricks is sort of a new generation of that approach. So we've had traditional, on-prem SQL data warehouses going back to the 60s and 70s, right? And then we had cloud databases, right? And a lot of that could be your Hadoop, it could be your data lakes. It doesn't just have to be like a traditional SQL data source, right? It's just this idea of distributed data processing. And then finally, what we're seeing as a true third generation of that approach is Apache Spark, and specifically Databricks as a hosted instance on Azure of Apache Spark. And so really one of the biggest benefits is that Databricks is a platform, right? It's not just a collection of utilities. Like if you took all of the different applications or tools that you have installed on your phone, right, and had them as physical entities in, a backpack, or at this point it might have to be, a duffel bag or something, right, with all that phones can do, that's going to be far less of a utility than having all that packaged on your phone, right? And similarly, if we went back to the old paradigm of manually installing apps, right, and managing software lifecycle on the user side instead of on the platform side, you're going to have a lot of pain points. I'm sure we all remember back in like the Windows 95 days of wondering if a certain application would install given your, driver configurations, or maybe even issues with your, particular chipset on your motherboard, right? Whereas nowadays, a lot of people could not tell you the point version of their favorite application, right? They could maybe tell you which operating system version they're on, right? But ultimately, we don't have to worry about those things anymore. And that's what Databricks is doing as a data platform. So you get essentially the same type of unified SDK that you might see on iOS for Android, where the things that the platform allows you to do is greater than the sum of its parts. So in the same way, when you add, an event to your calendar, and then your Maps app has that as a suggestion about, where to navigate to next, when you're in Databricks, you get similar integration between your ETL and your ML. Your streaming services are going to work natively with your nightly jobs. It's a comprehensive platform that you can build on top of. And so going back to that sort of third generation paradigm shift, the biggest thing that we've seen emerge from this is the data lakehouse paradigm. And so if you look over at the right, it's been called a unified analytics platform, but really the way I like to think about it is the combination of a data warehouse and a data lake, where each of the previous iterations kind of had their own limitations. So like with data warehouses, they're really only great for structured data, right? It's expensive to scale out. Typically SQL only, you're using it for BI use cases, right? And the data lake kind of came in adjacent to that, but it brought its own issues, right? MapReduce is typically pretty slow and it's hard to program. There's a lot of disparate tools. I don't know if anyone has seen, I think it's a little like Git stub, but it has you guess whether a certain name is a big data tool or a Pokemon. And that really has always driven home to me the tool complexity and just how wide the ecosystem has grown, right? And you really still can't scale up computing resources the same way you'd like, where storage scales differently than compute. There's always inefficiencies there, right? And so what we've seen with this unified analytics platform idea is the ability to fastly iterate on experiments for machine learning, having strong collaboration between your data science and your business unit, and the ability to simplify complex ingestion processes. So basically it's taking the best of both worlds and trying to solve those problems. So graphically, and this is a slide from Databricks that I've always really liked. So graphically, we can sort of see more and more things get pushed down into the compute layer. So instead of ETL being this discrete process here, when we had the data lake, you're sort of pushing everything into the lake, and then different components of your data infrastructure can fetch it. So you can see here, like our data science and ML side is doing one pipeline. Our real-time team is doing another. Our BI team is going through our data marts and doing yet another, right? And the idea with the lakehouse is that we have a single layer that's handling our compute, our automation, and our storage. And then all of these teams, your BI, your data science, whatever, are all pulling from the same infrastructure and the same data sources. And so if you clean up data for one unit, you're inherently also cleaning it up for another unit, right? And so that's been a huge change. And so the lakehouse really has these primary features that differentiate it. So you still get your ACID transaction support like a warehouse. You still get schema enforcement. You still get BI support. A big one that I've come to appreciate is storage being decoupled from compute so that you can independently scale, unlike your Hadoop data warehouse. And that proves to be huge for a lot of use cases. Support for diverse data types. So you can have your ETL pipelines that handle your structured data also handle unstructured and vice versa, right? And then end-to-end streaming, which is what we're going to look at today. The ones I skipped are important too, and I can provide this slide deck at the end, but we've got a lot to cover today. So we've talked around Databricks, but really what is Databricks? So we've talked about how it's a unified data analytics platform. It's a platform that unifies data science, engineering, and business. And some of the key features are optimizations for the cloud, cost management, built-in exploration tools, built-in production deployment tools, and security features. That's it. That rolls off the tongue a little bit better than, it's in a managed instance of Apache Spark and Hive and, all the other things that, when you look at really what all this includes, goes into more detail, but, at a high level, that's a good way to think about it. So really, we're moving from this idea where we saw all those disparate data pipelines between an engineer, a scientist, and an analyst, right? And a lot of that comes about naturally, right? Where like a data engineer might be working with Hadoop, which like, God bless someone who's trying to do machine learning with Hadoop, right? Whereas a data scientist might be using PyTorch and doing deep learning. Well, PyTorch isn't great for ETL, right? And so really, both teams are naturally siloed. And so what Databricks is doing is unifying that tool set so everyone can be working on the same platform in the same environments using shared notebooks, data sources, et cetera. And so really having this continuous life cycle, these directional arrows aren't that obvious, but really we have this life cycle that unifies engineering and data science under one platform, and that solves this huge data management and data science challenge that we're seeing in the industry, right? So you get the idea that data is the new oil or data is inherently valuable thrown around a lot. And I don't disagree, but there's more detail that needs to be shown. So like, a couple weeks ago when oil futures were hitting negative prices, right? I imagine that no one on this call was swooping up barrels of oil to just store in their apartment, right? And that's not because oil isn't valuable. It's because you don't have an oil refinery, right? You don't have some way of extracting that value. And so Databricks is able to handle this entire data pipeline to extract value from your data, where you have engineering components, preparation components, and analytical components, all built on top of the comprehensive features like administration, lifecycle management, monitoring, automation, et cetera, right? And so really that's our goal here, is we're looking at this value extraction pipeline from your data. So at a high level, we're looking at the unification of these data lake and data warehouse features for that pipeline. So you can see some of the highlights there. Parallel scale out big data capabilities are coming from your lake, right? The ability to have all historical data for your company, whether it's structured, semi, it could even be video files, whatever it might be. It's worth keeping at this point because of the ability to scale out your data lake. And it provides a raw sandbox for data exploration, right? Along with multiple engines for compute, whether you're using batch, real-time, streaming, search, whatever it might be, right? And then with our warehouse component, you still have the ability to deliver your data to end consumers, right? For BI tasks, you might be pushing it into Synapse Analytics, right? Whatever new paradigm your users are experiencing in the BI space, you're going to still be able to support it with this data platform. And ultimately, having pristine modeled data sets from the data warehouse is still achievable. I don't think anyone who's a data warehouse fan would be willing to give that one up, right? Another thing we're seeing is the broad expansion of tools for both data engineering and data science. This slide is specifically looking at data science. We collected this list of tools around a week ago, and it's probably already out of date, right? I'm sure a lot of you who have messed with data science have used a lot of these, and it can be a massive pain to support these ecosystems, right? So you might be using, Python 3.8 for a lot of your production deployment, but there might be a pandas extension or something, right, that only works with 2.7. And so managing your environments, your dependencies has turned into sort of a data ops or ML engineer task, right? And really, that time that data scientists are spending managing their virtual environments for Python is time that they're not doing actual data science, right? And so since that complexity is unlikely to go down anytime soon, Databricks has sort of taken a different approach to it. And they have what they're calling their ML runtime. And so it's essentially a managed cluster for Spark that you can deploy, but they're managing all of those dependencies and libraries for you. So if you're using the ML runtime, you're always going to have the latest version of pandas. You're always going to have the latest version of scikit-learn, whatever it might be, and they're all going to be mutually compatible, right? Because it's all being managed on the cluster side rather than on the user side. They're also deploying some really neat features through MLflow and Databricks Delta to support engineering and data science work. So you can sort of see here different ways that it's supporting data prep, model building, and model deployment, right? And so that's MLflow. That is going to be our June session. And then Databricks Delta is going to be the next session, the May session. So that should be good, and we'll dig into that more. So hopefully the question has been answered already, but in case it's not clear, why Databricks? We want to be able to combine our engineering and data science teams. We want to be able to support streaming natively, reduce our technical debt, and achieve that drive to value faster. So that is the idea with Databricks at a high level. I want to open the floor real quick if anyone has any questions about this content. Don't all speak up at once. I know I didn't do that good of a job. Okay, we'll go ahead and move on to structured streaming then. So let me pull up that deck. Okay, it came up on one of my other monitors. 1 second. Okay. So this is a set of slides actually from Databricks. So this is focusing on structured streaming. So if anyone has worked with streaming before or hasn't at all, this is sort of just a comprehensive approach to how Databricks sees it. I tend to like their paradigm for streaming, but if anyone has worked with other tools like Kafka or Event Hubs or whatever else and has questions, feel free to speak up. So we're only going to look at part 1 today. So that's going to be looking at developing streams. What is streaming? Why do we want to use it? And concepts to think about stream characteristics while we're using it. So let's start with the why. So really, when we think about what streaming is, right, we're thinking typically about processing engines, right? Whereas really what we want to think about is the actual nature of the data that's coming in. So we want to think about stream versus batch, right? So when we look at these concepts, there's really 2 completely different concepts going on here, which is stream versus batch, and then bounded versus unbounded. So streaming is basically data that's coming in real time, right? Where like it could be, at the level of granularity of 1 record per second, right? Or we could be doing streams in chunks of 10. Either way, it's a continuous stream of data, whereas a batch is sort of a discrete predefined chunk, right? Same thing with bounded and unbounded data sets. And so when we think about how to do our processing, you should really be thinking about how we want to process per run. So if we want to do a bounded or unbounded data set, and then, you know, when we look at that, when we look at a batch processing engine, it has the ability to do one big batch, right? Like that could even be, you know, a billion or a trillion rows at this point in a batch. Whereas if you're using a batch processing engine for an unbounded data set, you're sort of in a paradoxical situation, right? Where you could grab every single record, but then while you're doing that, another record's going to come in, right? So there's just no way to do it. Whereas with the stream processing engine, you can actually do both unbounded and bounded very well by using mini batches. So really don't think about it as streaming versus batch. Think about it as unbounded versus bounding data sets when you're approaching it for your problems. So when we look at this graphically, what's really happening is, so anyone who uses data frames quite a bit in Spark is familiar with the idea of distributed rows within your data frame at this point, right? So really all tables have this sort of approach where they're not together in memory like they would have been traditionally, right? And so that fits really well with the streaming concept where certain chunks within your stream might go into one node, some might go into another, right? And really they're all just being appended onto this unbounded table, which is kind of a cool idea when you think about it. And so the reason why we would use streaming versus batch is because streaming actually can handle a superset of the use case requirements for batch. So it can deal with unbounded data while providing lower latency, and, you know, even when that, you know, sounds great, a lot of you are probably thinking like, isn't that going to be expensive? Won't my clusters always need to be on? You know, batch still sounds a little bit more appealing, right? So the way Databricks handles it is that you can schedule a stream to only process currently available data, shut down, and then come back again when there's more data. So that's part of that automation and cost management that we've talked about. So when you think about stream processing engines, some of the huge topics that you start to think about are correctness, right? Whereas like if we are pulling in a batch of data, that's the data, right? Like we can look at it, we can feel it, we can inspect it. Whereas with streaming, you know, it's kind of like trying to collect droplets out of a hose. Like you know, even if you got a full bucket of water, you still are kind of convinced that there's going to be a little bit on the grass or whatever, right? And so correctness becomes a huge challenge to get correct. And so you want to have the same level of correctness that's on parity with batch streaming. So you need the exactly once guarantee. You also can't cut corners with approximation. So that's the way that the Lambda architecture has always handled it. And you also need to be able to deal with out of order events. So if your cluster comes back online after an outage, you don't necessarily have, you know, want to just leave all that data. And then how do we think about when we reach a point where we get beyond batch streaming, right? Like what tools can we have for reasoning about the time to get beyond batch? And that's where this structured streaming starts to come in. So when we think about time, we have to think about time domains. So you have to think about event time versus versus processing time. And one of the tools we use here is watermarks. And so when you have your event time, or the time that the event occurred, and the processing time, what you can basically do for unbounded data to get it processed in, you know, this somewhat random order while still obtaining correctness is essentially just labeling your data. So watermarks let you handle late data, or when the event time is skewed past your processing time, you can sort of keep track of, oh, I've already seen this come through before, right? And we'll look at that a little bit in the example. So the time domain skew is essentially a big difference between batch processing. So like if we look at this line here, think about that as your batch, where every minute we're going to do a set number of records and they're going to be processed at the same time, right? Whereas with a stream, the time that an event gets processed is not necessarily the same time that it actually happened, right? It's a little bit more wiggly. So when your processing time is later than event time, you can assume your data to be complete if all the event times, or sorry, if your processing time happens after all of the event times, right? Basically, we're settled, we've got the chunk of data. Whereas for stream, the processing time is always going to be greater than or equal to, right? Typically it's going to be close. Like we're probably, running micro batches at the second or minute level. But if the processing time far exceeds the event time, like if the data is coming in very late, then it's harder to conclude, how long to wait for the data, like when it's going to be complete, right? And that's why the watermarks can be handy. So some concepts to think about when you're looking at streaming characteristics. So we want to think about what results are calculated, right? Think about that like transformations. And then where within an event, the event time rather, are those results calculated? So we can use event time to get correctness, but not all use cases are about time. Like honestly, the easiest examples to do with stream processing are whenever we do have a time component, right? But there's going to be all sorts of cases where we're looking at different metrics to evaluate correctness or to evaluate our data. So then we have to think about when during the processing time are our results materialized. So that's typically a combination of triggers, watermarks, and what your output mode is set to. And then finally, how do we refine those results? So how are we going to accumulate the data? How are we going to basically transform it into a meaningful result? Because typically your end users are not going to be consuming a stream. It's going to be going back to some sort of batch, probably coming out of your data lake, right? So when we think about what results are calculated, like I said earlier, we're typically thinking about transformations, right? That's your selects, your filters, your group bys, things from the data frame API. But some data frame operations are not supported in structured streaming. If you looked over my shoulder while doing structured streaming development, you would probably be shocked how many times I try and do something to a data frame before remembering that it's actually a streaming data frame. Now, there are workarounds, but certain things just don't logically make sense. So you can't do multiple streaming aggregations. You have trouble doing limits. You have trouble doing distinct. You can't do all join types. And a lot of this, if you stop and think about it, it comes naturally from the streaming paradigm. It's not, a limit of the API. It's just one of those tricky things when you're thinking about a new paradigm for data flow. So then let's talk about where within event time results are calculated. So that leads to windowing. So when we talk about windowing in a SQL environment, it tends to work. Sorry, one second. My PowerPoint, I think, froze. Yeah, so when we think about windowing in SQL, it tends to work similarly to how it does in structured streaming. The key thing here is that we're typically using windows that are based around time. So basically, when we think about doing transformations to streaming data, you might window it in 10-second batches or 2-second batches, right? Where like you can see each of these have 10-second boundaries, but they're 2-second offsets, right? So that would give us 2-second deltas if we were looking at different windows of data. Or you could look at it as discretely as actual, sessions or chunks, like where a particular user is logged in, right? So So we were just talking about event time. When in the processing time are these materialized? Well, that comes down to the trigger and watermark idea that I keep hinting at, right? In output mode. So really, this is all stuff that you're going to control. We'll look at it in the demo. This is something that requires a little bit of reading. There's actually, I think it's called the manual to structured streaming, available in the Databricks documentation. And that's really all I ever read to get a hang of this. It's a really good write-up and good material. And a lot of these graphics are coming from there as well. So with triggers, you can either do an unspecified trigger, that's the default. That makes it so that a new batch starts immediately after the last one completes. You can also do a fixed interval. You can say start a new batch only after the last one is completed and a certain amount of time has passed. Or finally, you can do a one time. One time is cool because it can sort of simulate batch processing using streaming logic. So one of the things I found myself doing is actually moving over to, and we sort of hinted at this earlier, but moving over to structured streaming even for my batch processing. Because if you remember that early slide that was sort of showing the differences between batch and streaming processing, streaming can actually handle both use cases, whereas batch can only handle the one. And so if you start off thinking like you're doing streaming for everything, then you're going to have less migration costs later on when things change. So let's look at an example here of using windowing and a trigger. So we could do this this window on a 10-minute window with a 5-minute delta, right? You can sort of imagine that graphic. And what we're doing is we're grouping this words data frame on each word, and we're doing a count. And what we're going to do is we're going to process that every 5 minutes, right? And so if we look, we have this these input streams of data frames coming in with different words, and every 5 minutes, this trigger is going to get called, right? And so let's look at the results table. So initially, since we're doing a group by word, we count that there's 3 counts of dog in here, right? So we get dog is 3, cat is 1. When we do it again at 12:10, we get the count for cat, dog, owl, cat, and owl, right? Because the windows of time also matter here. So essentially, this stays like it was, and we're sort of appending these new results for these 2 new batches, right? And then similarly, when we have these 2 new results coming in between 12:10 and 12:15, the counts are incremented for these 2 windows, right? So basically, because we have this rolling 10-minute window, but we're doing 5-minute triggers, at each point, like either this and this are going to get updated because it's comprehensive of this entire range, or this and this will get updated because it's comprehensive of this entire range. So it's essentially the 2 windows on either side of the event times that are going to get updated. And so you can see how this can be a pretty powerful technique for processing streaming data. So then we want to think about, if we can't expect data for a certain event time window, how do we handle that when it comes in late, right? And so that's where watermarks finally come in. So this is a way of marking the most recent event time that you've seen, and then configuring the lateness threshold to actually discard late data after it comes in. So this is sort of the same way that you would like keep track of something that you were counting by hand. It's a pretty simple and obvious paradigm, but it's really powerful. A good thing to keep in mind is that with structured streaming, you only get a one-sided guarantee to not drop data within that lateness threshold. The late data could still be processed based on when the watermark gets advanced. So like if the watermark got moved before the late data came in to be dropped, then you might accidentally end up accepting it later. So that requires some extra engineering to handle, but it's not the end of the world. So let's look at an example watermark here real quick. So we can go ahead and just tag our data frame using the with watermark method. And we're going to use the timestamp in a 10-minute window to sort of create our watermark. And so if we look, if this is our stream, this data from 1204 came in, but because we processed it at 12:15 and it was more than 10 minutes late, it is not going to actually update the count for dog like it would normally. So we're only incrementing the 12 to 12:10 window instead of the next window. So that's how we would handle late data using watermarks. So then let's talk about output real quick. So what and when do we output to the sink of the stream? That's the output source. So we can choose different output modes to handle that. You can choose complete. That outputs the complete table every time the trigger materializes. This is what we were looking at in previous examples. Notice we had the whole table at every step. We have the update mode. That also materializes every trigger, but that would only output new values. So if we look at the previous case, at each step, we would only be outputting this chunk or then this chunk. Anything, and really, I guess anything in the middle too that changed, but we're not outputting stale results. And so you can imagine for larger streams, doing update is pretty crucial. And then finally append, that only materializes after the watermark and lateness has passed. So that basically guarantees that anything that we're returning isn't going to change later. That's a really smart way of handling that lateness issue I mentioned, where the watermark could go past the lateness period and you would accidentally get late data. So if that's really crucial and you're not doing deduplication on the sync side, then you want to be able to do an append. So let's look at an example of the output mode. So if we were doing update, you can kind of see at each phase, these purple rows are the only rows that get written out to the sync because they're the only ones that have been updated. So by 12:25, because of the watermark, we're not going to be handling anything from the earlier batches. This is a nice graph too because it again contrasts the difference between the event time and the processing time. And you can also see our watermark time here and how it sort of cuts off anything that falls below it. So when donkey comes in, since it's below the watermark on our y-axis here, it's not going to get included. And our watermark should always be 10 minutes behind our processing or our event time. So that's the idea of output mode. Let's look at the append mode. So in this case, we've got, again, two things coming in late. Unlike the previous mode, the update mode, since donkey came in after the watermark and we've already batched out everything before that, it is not going to get included in those final counts. So the way it would work is between 12 and 12:10, notice we don't have a watermark yet. Between 12 and 12:10, everything's maintained as internal state just in case we have late data. So it's not in the results table. And then finally, once we hit 12:10, those final counts are added to the table. And then when the watermarks that are greater than 12:10 come in, that late data is counted and the intermediate state for that window has to be dropped. So basically after each trigger, the 5-minute trigger, you're getting this result sent out and then this result sent out. And you can see, since this already got sent, this grayed out piece, we're just appending the new results to it. So this is less dynamic, but on the results side, you're getting a better guarantee of not including late data and your counts being right. So if you're doing a real-time streaming dashboard, this would not be a great tool to use or a mode. But if you're doing something where you're processing streaming data, but then you're going to consume it in a batch mode, this could be really great. So let's look at the refinement of these results. So the way that accumulation works for streaming is a little bit different than batch, like we said. So you get the ability to discard. So that means whenever a specific event time interval is materialized, you can have the old state discarded and only the new is output. We've seen some similar ideas to this in those output modes. You also get the accumulation mode naturally. That makes it so that whenever a window of an event time interval is materialized, the old state is actually added to the new value and then the sum is output. That can be useful in a lot of cases as well if you're keeping track of, like, say, the number of times a certain hashtag appears in your streaming data. And then accumulating and retracting, it's an extension of accumulation, and it makes it so that you are getting both the sum, like the new value, as well as the value being overwritten. That makes it easy to compute deltas and do some other data integrity guarantees and checks. And then let's look at the data flow model for looking at streams. So we talked about results being calculated using transformations, the results in event time being handled by windowing. You know, if we look at where within the event time results are being calculated, it comes down to windows. And then the when for processing time those results are materialized, that comes down to our triggers, watermarks, and output modes. And then how do the refinements of the results relate? It's the accumulation modes that we just looked at. So that's the idea. And we'll cover this this part 2 of deployment probably later on. I could see that being in July or August. It kind of ties into what we're doing with ML flow deployment. But I just wanted to focus on part 1 today. So before we go over to the demo, does anyone have any questions? I know we went kind of fast, and that's pretty dense material. Okay, cool. So let's go over to the demo. Okay, so what we're going to look at today is an example of, and actually I wanted that window. We're going to look at an example of sending tweets onto an event hub to create a stream. So basically doing that streaming output. And then we're going to actually collect those tweets back from the Event Hub stream and apply Azure Cognitive Services on top of them in real time to get the sentiment of those tweets. So I wanted to go ahead and grab a trending hashtag. So let's see. Let's do hashtag aliens are real. I'm sure that'll have some good sentiment. And so what I've got right here is a widget. And so I can fill that in and then grab that, and it's going to grab my search term for me. And then down here, I don't necessarily want to focus on the code unless we get some questions about it. I want to leave some time open for discussion at the end here, but really all we're doing is instantiating a connection to our Event Hub. Notice I'm using our Databricks secret scopes to get my Event Hub connection string. And we're going to instantiate an Event Hub client using that connection string. and then set up a connection to the Twitter API and go ahead and start writing off some tweets onto that event hub. So let's go ahead and get that started. And so we can see our streaming tweets coming through here. Seems like everyone's pretty confident about aliens being real naturally. And then over on this side, we're going to go ahead and instantiate that connection to the event hub again, except this time we're going to create an incoming stream from that event hub and process it. So let's go ahead and run that. And we can see this batch coming in. Now, immediately, we've got a problem. So our data is coming in, and I don't know if anyone can read that, but I'd be suspicious that you're a robot if you can, because it's coming in a binary format. So the way, one of the optimizations that Databricks has, and the way that it processes streaming data is by serializing it. And so this is much more efficient to send across in the Event Hub, but it's not great for sentiment analysis. So we're going to go ahead and cast this as a string type instead and process it that way. And then we'll actually be able to read it and do our processing on top of it. And sure enough, we can see this coming in, and we've got our offset, our readable time, and our Unix timestamp along with the body of our tweet. And that's enough to do our streaming analytics. Now, we're not going to be looking at any watermarking or windowing today. You could easily extend that using those tools, but our use case is more around data enrichment right now rather than the cleaning phase. So in this step, I'm defining the Scala classes that are going to go ahead and handle my data types for both the tweet and the cognitive services. So down here, I'm going to go ahead and define some methods for that class. These just instantiate the connection to cognitive services and handle some of the API calls. So really, we've got two things here from cognitive services: the ability to get the language of a tweet, and then that language in the body of the tweet is fed into the get sentiment so that we can get a sentiment score. If you put, German into an English sentiment analyzer, it's just not going to work very well. So we need to detect the language. And then here we're defining a user-defined function that we're going to pass into our data frame API. And this is what actually extracts the sentiment of the tweet. So we'll define that real quick. And then here we can see we're going to select the body, and then we're going to add a column called sentiment, and it's going to use our toSentiment method that we just defined. And we'll go ahead and run this. And sure enough, we can see that we're getting some positive sentiment coming out about aliens, some negative. This person sort of being a Debbie Downer about it, so they get a lower sentiment score. And that's the idea. This is a real-time stream coming in from Event Hub, and we can sort of see our data flow rate coming in here. We're getting about 1,000 messages an hour here is the rate. And that's the idea. So I want to go ahead and open up the floor again for questions about the demo. I can dive deeper into any of these pieces of code if needed.
Can you share with us the notebook?
Yeah, absolutely. So let's go ahead and do this. I'm going to go ahead and clean up one more thing. And then, So what I'm doing right now is I'm adding a note so that you guys remember to create a secret. And then I'll go ahead and just share the folder. So one of the cool things that you can do is a Databricks folder or notebook is really just some markup on top of either a Scala or a Python script. So it's really easy to share and collaborate even if you're not sharing a workspace. Okay, and I'll go ahead and share this. Okay, so that will be available in the chat here in a second. Okay, any other questions? Okay, so let's move on from just focusing on the demo. And this would be normally we're going to try and split it into about a 30 or 45 minute presentation and then 30 or 45 minutes of group discussion, sort of just free form discussion about Databricks or related technologies. I went a little long on the presentation side today because normally we aren't going to be, doing an intro to Databricks more broadly. So if anyone has topics or questions more broadly, now would be a great time to go ahead and bring it up. Otherwise, I can fill the time with more of my rambling. Any cool things you've been doing with Databricks or the Azure data stack?
Well, I mean, first off, I'd like to say the streaming conversation is pretty relevant to what I'm doing now. For my customer, we're getting ready to go into we're streaming and then also the whole conversation around the Delta Lake. So, and I'm new to Delta Lake, so that user group meeting is going to be pretty relevant.
Awesome.
Have you and I've only cursory messed around with it, but connected Databricks into Azure Data Warehouse or Azure Synapse?
Yeah. I've had 2 or 3 projects where that was one of our endpoints. And what's kind of wild about it is it connects the same way that you would connect to a traditional SQL environment. It's just using that JDBC connector. I forget the name, but it connects just like a traditional Azure SQL database would.
Cool. Thanks.
Yeah, absolutely. Yeah, and one of the things that I want to talk about, I haven't quite nailed down how, is, Synapse is offering to do a lot of the same things that Databricks is. It seems like really, if you looked at the architecture, it's really just about the difference in emphasis between Databricks, like being a compute engine, versus your data warehouse. So Synapse is naturally going to be focusing more on the warehouse, right? And so really, like, they're both data lake houses. They're both unified analytics platforms. It's really just like whether one component is more important to you than the other. I can sort of peel back the curtain. Like, I really like Azure Synapse, and I've done a lot of analytics in a day workshops around Azure Synapse, but we sort of see the emphasis on the lake and the focus on compute as being probably more the correct play versus the focus on the warehousing stuff, but both are really relevant right now.
I had a question as well.
Yeah.
So when you're doing the streams, I was kind of wondering how you balance between the partition sizes. So for instance, you're doing a merge during your stream. So kind of balancing it for being fast for the stream, but also fast for users to pull it out.
So are you familiar with the bronze, silver, and gold zones for Databricks?
I am, yeah.
Okay. So typically, I would worry about that at the silver or gold level. For bronze, we don't typically partition as much. We're typically just putting the data into the lake pretty raw, non-partitioned. Now, if you're starting to get into huge batches, huge micro batches, which I know is kind of an oxymoron, but it can happen. Then you might have to apply some sort of partitioning in place. We've, like for App Insights streaming, we've done that on the event time previously, and that's been okay. But typically we try and handle it in that next level in the data infrastructure.
Thanks.
Yeah. And so anyone who hasn't seen that, there's this paradigm that's really popular with the Delta Lake. And let me share it real quick. So it's this idea where your streaming or batch are going straight into ingestion tables, and then you move or consume the ingestion tables into refined tables, and then finally you push the refined tables into your feature or aggregation data store, and that's where typically end users are going to be consuming from. So that's the idea there. And typically, yeah, sorry.
Go ahead.
I was just going to say, and typically these in between steps are also where we're doing a lot of our partition logic. You know, you can really do it in place too, but if you read a lot of the documentation around Delta Lake, it seems like that's where they intend you to be doing your partitioning.
Yeah, I was wondering, we are working with a customer on the IoT analytics platform, and the customer wants to use this gold data in a web application. So we had to build a web API on top of the data lake. Is there any better way around this? Do you have any experience?
Yeah, so we use Cosmos DB for that a lot of times. And so you often have to change your tables a little bit. So Cosmos is trying to think of the best way to articulate it. Really, it's a globally distributed key value store. And so it's great for web applications because you get a really high degree of locality. Now, your key value store obviously loses a lot of the benefits of a relational database. But if you think about that particular application, it's a lot easier to modify your gold data or your syncs for your data output to conform to Cosmos than it is to try and make a web application performant querying against a data lake, if you know what I mean.
Yeah. Okay.
Yeah, so that's how we've done that in the past. And really, if you look at the way that Databricks presents it in their internal documentation, they want like this core compute to be as broad as possible, right? To be able to handle whatever type of computation or transformation of your data you need, machine learning, whatever, in a fast, efficient, modular way, right? Really, then everything on the outside, the input and the output, is highly modular and application or task specific. So if you want to pull in, some unstructured data off of an event hub, you should handle that differently than pulling in batch data from SQL, and really like heavily lean into those particular use cases. So your inputs and outputs are highly specific, whereas everything in the middle is agnostic and can work for a variety of use cases. Does that make sense?
Yeah, sure.
Yeah.
Another question is, so if you have like the streaming data and you're dropping it due to the watermarks, what if you don't want that data dropped? Like for instance, you're rolling it up to like taking the max at each one and old data comes in. Is that something you would have something else to go back and kind of clean up the tables, or?
Well, yeah. So let's be clear. Everyone should be collecting all of their data, period. No qualifiers. If something is coming across to you, that should be going somewhere in your data lake. Now, the example we were looking at was, let's say that you had a real-time dashboard of how people are responding to a certain one of your products on Twitter, right? And you're literally using that use case we just demonstrated, where you're counting the number of times the hashtag appears and maybe some sentiment, right? What you don't want is if you're looking at rolling 5-minute windows for suddenly something from a half hour ago to come in and suddenly tank that score, right? Because for something like a presentation, like again, you're doing an announcement, watching it in real time, you want to get the current pulse of the audience. You don't care about what someone 30 minutes ago thought before they had got the full story, right? Now, what you would do is not have that go to your dashboard. That would just go to your lake, and it would still be available in the bronze zone, because maybe after the fact, you want some data scientists to do some sort of natural language processing model on top of all the tweets that you consume during the presentation. So you need to approach both cases and understand what data is going to which particular case, but ultimately you're collecting everything.
Perfect, thanks.
Yeah, absolutely. And so in the real world, what we've done is have a master stream, and then you could have multiple streams that pull from that. So in the same way that you could have a source data frame, and then you could have 4 or 5 or whatever data frames that all are different filters or aggregates from that initial data frame, and you're sort of getting this tree structure. You can do the same thing with streams, because it supports all the same manipulations that a data frame would. That's actually a key component that I neglected. Like, I normally just really wear out the point, but one of the coolest things that we're seeing in streaming code is how easy it is to transition between batch and streaming. So really, if you wrote a bunch of batch ETL logic, you're just changing the name of one parameter to convert it to a stream. So if you're doing blah 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 dot read, you literally just have to change it to .read stream, and now all of a sudden you have a streaming data frame instead. So it's really easy to design complex ETL logic and have it apply to both batch and stream processing. You don't necessarily have to like buy into one in particular. Oh, I almost forgot. We are going to have a survey in the chat. So I just sent those notebooks across, and I think Lindsay or one of the other moderators is going to post a survey. That would be a good place to give us some ideas for future topics, and also just let us know how the initial session went, you know, all that good stuff. You've taken surveys before. It's weird. It's not wanting to upload that folder. I think it's because of the extension. So let me try zipping them up. I know that Teams is not a huge fan of you sending raw code to people. I can't imagine why. Okay, and that survey is available in the chat. Okay, does anyone else have questions right now, or broader discussion? It really doesn't have to be just me answering questions. I'd like to, you know, hear how other people are using Databricks and all that good stuff. I think that there's a lot more commonality than we realize in our workflows here, and we're sort of part of a niche group of people who are using this bleeding edge tool.
Have you had a chance to try the Synapse preview?
Yes. So I think Lindsay would know better. I think we're going to have another one of these sessions actually coming up, but as part of the analytics in a day workshops, we actually get a hands-on lab provisioned. And so you get the Synapse Analytics preview, and it's already like pre-configured against the data lake and Spark environment. And so the 2 or 3 of those I've led, along with some like instructor training, was a really cool chance to like actually dive into what it actually looks like in production without needing to apply for that private preview and then, you know, set it all up. And honestly, it's a little bit expensive for experimentation. Like you could probably do it on an MSDN, but your like MSDN license, the credit you get, but you're not going to be doing petabyte scale analytics for $200 a month. You know, like you might get to do a 5-second demo.
And were you able to explore like how that works with Delta Lake? So pretty much using like the Azure, like the warehouse machines with the same platform?
Yeah. So essentially, the way that Delta Lake is exposing its tables is generic enough that it was able to be imported. Now, what I would be concerned about is as Delta Lake gets more unique features that are integrated with Databricks specifically, how that's going to look. So, and like, let me point out real quick what I mean by that. So, where'd my screen go? Okay. So, like over here, there's now a native integration with MLflow for your models, right? Where it's an actual tab, you can see your model registry, et cetera, right? Similarly with data, this is the Databricks file system. And so we can see globally registered databases or tables that we've created within the Databricks file system. I envision pretty soon, if not as part of like this conference they typically have in June in sort of the 3.0 release, if we're not going to get that type of integration for Delta Lake tables as well, where it's, you know, easy to manage through the GUI. And so I could see that making it tricky to sort of manage the two. What we've typically done, if you go back to that bronze, silver, and gold, is we're doing delta for bronze and gold, and then we would push out those tables to Synapse or another data warehouse as a sync. We wouldn't necessarily be using the same tables for Databricks and for Synapse, just because that could get a little bit messy having two different compute engines manage it. Do you know what I mean?
Yeah, that makes sense.
But the Spark engine that Synapse is running is the same Spark that these clusters are running. So it's not like, you know, there's that difference.
Yeah, the main goal was it to give like other employees or other coworkers access to the data without having to spin on a cluster and wait for it to get booted up.
100%. So here's the deal though, the self-service users don't typically need the features of Delta.
Okay.
So, well, so that's why we would be writing it out into either a Synapse table within that data warehouse or to a SQL table. Any of those outputs are sufficient, and then from there, you know, push it into Power BI or whatever else. We're definitely not, at least no one I've ever encountered is running a cluster just to like point Power BI at it, right?
And for doing it into the SQL tables, like since you have late data come in and you want to do like a merge, no duplicates, how are you running that from the Databricks side?
So typically, I've just called stored procedures that handle the upsert. Azure SQL has some nice features for Delta style upserts that work pretty well. It also has isolated transactions. So we've never had an issue where like we're updating a table while someone's reading from it and you get a deadlock. You know, we're sort of past that point. It seems like. Another technique we've done or seen is managing all of that on the Delta side, and then the SQL side is literally just a mindless table. Essentially, every time you do an update, you're dropping it and reloading it from scratch. Now, that gets expensive on the IO side, obviously, versus just doing appends or upserts. But for smaller tables, like say fact tables instead of dimension tables, that's an okay way to do it.
Okay, yeah, I could see how that go out.
Yeah. I mean, ultimately, the point of that initial Databricks presentation is that this is just Legos, right? Like, you still have to understand your data and you still have to make intelligent engineering decisions about your, business processes and supporting that data. What it's going to do is give you every component to implement those choices. Instead of you being boxed in or siloed into particular ways of approaching problems, you've got the whole toolbox now. And so if there's some intelligent approach that you read about on Medium or whatever, you're going to be able to bring it over and do it on Databricks. You're not necessarily installing some only mildly supported Hadoop ecosystem tool to try and do it. Oh, and by the way, in the survey, you'll be able to throw out any topics you want to see for later. If anyone has things they'd for sure like to see covered as part of the Delta presentation, feel free to just tell me now, or we can sort of spitball about what we want that to look like together. All of these topics could be like a whole week of a graduate level course. So it's, I always have to be a little bit opinionated on what I choose to include or not in a shorter presentation. But it seems like we've covered all of our questions for today. So I'm more than happy to just give everyone 5 minutes back. But go ahead and grab those notebooks from the chat. They got uploaded, and fill out our survey, please. And then, come back for next session and bring some friends or colleagues, and we'll keep this going. Hopefully it keeps expanding.